Yeah. Yeah. Good evening, all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? So in the yesterday demo session, right, I was just briefing you about what is Apache Spark, why Spark, need for PySpark, right, and Spark Python versus Scala, right, and PySpark features, real-time usage of PySpark and PySpark job market. So Apache Spark, right? So it was developed in the year 2009. Spark was developed in the year 2009. It was open sourced in the year 2010, right? And it was donated to Apache Software Foundation. It is 2013, right? And it's a Spark is a open source distributed execution framework in parallel process style with in-memory computing feature used for large-scale data processing, right? So open source, distributed execution, parallel process, in-memory computation, and used for large-scale data processing, right? Okay. Today, like Spark is an execution model. It can be implemented in multiple languages, right? Like multi-language support, we can say, can be coded with Scala. It can be coded with Python and Java and odd language. So it's by default, Spark was built using Scala language. So today Python also mostly used for implementing the Spark, where Python has got many libraries, right? And Spark is okay. Can say Spark is an engine for big data analysis, processing, and computation. It's a kind of distributed cluster computing framework, which was introduced by Apache Software Foundation, right? And why PySpark? It is the Python API to use Spark, right? It is the Python API to use Spark. PySpark is used for distributed SQL, creating data pipelines, data ingestion into database, right? Running machine learning algorithms, interactive queries, graphs, and streaming. So the PySpark is mainly designed for batch applications, iterative algorithms. Most of the ML algorithms are iterative in nature, and interactive queries, right? Yes. Okay. Need for PySpark. Need for PySpark, if I say, right, what is the need for going for PySpark? So I was saying, like if data is generated, right, the data contains many hidden patterns, like market trends, customer preferences. So it is required to extract required information or valuable information from the raw data. So just extracting the required data from the raw data, right? So we require a efficient tool for performing these operations, right? We know that we have got many other tools, but to perform multiple tasks are at a high speed, right? And on that to processing the huge data sets. So this PySpark is one of the appealing tool, right? So it's more scalable and more flexible tool, right, for performing big data, working with big data applications. So combining both Python and Spark, combining both Spark for execution, Python for implementation, it's a very efficient for that world of big data. So that Apache Spark community, right, it came up with a tool called PySpark, that is Python API for Apache Spark. So I was just briefing you that most of them has got some dots, right, related to how to go to for Spark with Scala or Spark with Python. What are the differences between Scala programming and Scala programming and Python programming, right? Python is dynamic typed, Scala is static typed. Python is slower than Scala because of Python interpretation. Scala is 10 times faster. I'm talking about the programming languages only, but not about Spark and PySpark. If I talk Spark, by default, Scala comes. If I talk about PySpark, Spark with Python implementation comes. Spark by default, Scala implementation. PySpark, Spark with Python implementation. I'm talking about Python languages, but if I talk about, I'll just differentiate between Spark and PySpark. First, see that language wise, Python is slower than Scala because of Python interpretation. Scala is 10 times faster. Python has got huge community, like thousands of models, like nearly 89,300 inbuilt modules. It has got great and huge community, but Scala has Scala smaller community. And the applications wise also, if you talk like Scala has got very less applications as compared with Python. Means Python not only for this big data environment or for this, we have got many other applications for Python, right? Web applications, creations, automation applications, animations, gaming, right? Wide varieties of applications for Python. That's what Python contains powerful libraries for machine learning and graph algorithms. Scala has some weak libraries for ML, right? As compared with Python, I'm talking. Okay. PySpark features, right? PySpark features in-memory computation. In-memory computation means your storage and processing both happens within the memory level. So generally, data storing within the disk processing happens, right? Generally here, data storage and data processing happening within the memory level. In-memory computation, we say, right? So your data objects are going to be divided into smaller partitions. The partitions are going to get distributed across multiple RAMs of multiple worker nodes and are executed parallelly, right? We achieve high speed. Lazy evolution. Lazy evolution means here it's a data flow language. Spark is a data flow language, right? Means multiple flows. One flow output is the input to the next flow. So for example, if you take the entire data flow, right? If you take multiple, we say RTDs, right? The first step output is the input to the second step. Second step output is the input to the next step, right? In this way, it's a data flow. So the entire flow, right? Pipeline, the entire pipeline gets executed only when you perform some kind of action. If no action, it won't execute. On demand, we execute them. Lazy evolution, nothing but on demand, we execute them by making a call or by making a action. We have got many built-in actions in Spark, right? We'll be discussing all those one by one, when to perform. That is, transformations are there, actions are there. Built-in transformations, built-in actions. No need to write huge codings here. We have got inbuilt operations, functionalities, transformations, and actions. Fault tolerant model. Fault tolerant model means while processing, while computing, means your data objects divided into partitions, partitions distributed across multiple slave nodes, worker nodes, and are executing parallelly. They're computing parallelly, right? Then if any system goes down, right, then there should not be any data loss. They should, the job should not be failed. So it will recompute. So how this recomputation is happening? So PySpark has got a fault tolerant model, a good fault tolerant model, right? So whenever any system goes down, right, it is going to compute from its previous, that is, it takes the input from the previous RTD and recomputes and process it, right? Persistence feature means no need to re-execute every time from the beginning flow. If you want multiple operations, if you are performing the second or third operations, right, if you want to make use of already executed a transformation, right, already executed transformation, if you want to make use, then if you have persisted that, then it will be available in the RAM. Generally in that RAM, if you are persisting anything, means it will be available in the RAM. It won't be removed from the RAM, so that the other flows can use its output, right? The other flows will take the input of this current flow, right? So I'll be discussing in brief. Persistence features means no need to re-execute every time from the beginning. You can take the output of the already executed transformation and computing, right? Yes. So many steps are going to decrease. Distributed execution, right? And parallel processing. So real-time use cases, real-time usage of PySpark, right? So I was just saying in the commercial sector, it is mostly used. So in the examples like in banks and in financial sectors, so the Spark is used for retrieving the customer's social profile and gaining some useful insights from it, right? And also like extracting information like a credit risk assessment, that okay, and plays a significant role in fraud detections and used in machine learning tasks in commercial sector, right? In healthcare also, right? Today, like Spark is mostly used in analyzing the patient records along with the previous medical reports data to identify which patient is probable to face some health issues even after being discharged, right? And even in the entertainment industry, right? I was just saying yesterday, like it is entertainment industry is totally, it is growing, it is growing towards the online side, right? It's totally moving towards online side. You've got many OTTs, right? Online streamings, the popular, like if it, popular online streaming like online entertainment like Netflix uses Apache Spark for real-time processing and for personalized online movies or web series. So it I was saying it is Netflix, the so it process Spark processes approximately nearly 450 billion events per day that are streamed on the server side applications, right? Yes. And also it uses like Python API. Netflix uses Python API like Python modules like NumPy and CP, right? For security automation and for subscription purpose, right? Trades and e-commerce, right? Also I was saying about this trading and e-commerce side, right? So the top e-commerce sites like Flipkart, Amazon, all this, they're using Apache Spark for purpose of advertising, and also like some other websites like Alibaba provide some enhanced customer experience. And even in the tourism industry, widely used Apache Spark is widely used to provide advices to millions of travelers of the hundreds of tourism websites, right? Yeah. Are you aware, right? Once again. Yeah, once again, can you please confirm whether my voice is clear, whether the screen is not? So there was a power outage, so I was out of the meeting. So just I'm unable to access the network, so I'll manage to let off the demo set. So here I was just talking about the tourism industry and the real-time usage of PySpark. And see, many of the students yesterday, like they were asking where to go, like a Spark, like Python. So both Spark, everything is same Spark, but on implementation mostly used to Spark. It's Scala and Spark.
Vijay, your voice is breaking, Vijay. We are not hearing properly.
Try to confirm once that my voice is clear or not. You're getting some. So just go ahead. Actually, it's a power outage. This is the internet, right? I'm just continuing with other sources, right?
Hello. Hello.
Yes, yes, yes.
Your voice is breaking. We could not able to hear. You are not audible properly. Can you please adjust with your
Yeah.
connection?
Yes, yes. Just now there was a power outage. There is a power cut. I'm unable to access the internet, but I'm just going with the other sources. Right? So try to manage disturbing. So difference between this Scala and Spark Python, right? Yes. Spark is a interface which allows you for big data by combining the simplicity of Python of Apache Spark. As we know, I'm getting sounds. Srinivas, please be in mute. Sheshendra Srinivas, please be in mute. Okay. Both Scala language and Python are more excellent for developing data science applications. So which language is best between Spark and Spark? Completely depends upon your projects. Which I need, which is most, it depends upon your project needs. If you're experienced programmers, right? Python is the least choice. Scala on the other side, right? So is the way you need to have huge project that demands a lot of resources, parallel processing. Whenever you want to go for a project that demands a lot of resources and parallel processing, it's Scala and Python. That if it says Spark means Scala, PySpark means Python, right? So Spark, if I say Spark means Scala implementation default. PySpark means Python implementation. So should perform equally for both performs equally on data frame operations. Both languages APIs are great options for most of the workflows. Still, you're getting some Sound issues. Confirm is facing problem with sound. Okay.
You are not audible, Vijay, basically. We are not able to hear you properly.
Okay. Give me a second. So real-time usage of PySpark, right? Commercial sector, health, entertainment industry, trading and e-commerce, tourism and industry, right? Yes. So hope my voice is clear. Can anyone please confirm? Yes. Okay. Okay. Fine. Fine. Okay. If it is better. Okay. So there is a power outage. Suddenly there is a. So I'm going with other means. So just I'll continue for some time, and we'll continue. Okay. So let's some very fast. Some of the students like Spark with Scala and Spark with Python. PySpark is the Python interface, right, for Apache Spark. Both languages are excellent for. Language is the best between PySpark and Spark. It completely depends upon your project needs. All depends upon your project's needs, right? Python is a decent choice for it. Scala, right? Whenever you're working with a huge project that demands a lot of resources. So, but if you see the Spark APIs are similar to both the languages, right? If you see the execution model range for both. But Python, I can say it's a great option. Most of the workflows, it is naturally, it looks like normal English language wise, it will be very simple and easy and fast as when compared with Scala. But Scala, come to Scala, right? Scala has got, so it offers structures that cannot be offered in Spark. Change the network.
Vijay, we are receiving the same problem like before.
Yes. Yeah. Now you can check, right? Now you can check my voice. Hope it will be good. I've changed the network. Yes. Try to confirm once, everyone.
Yeah, it's okay, Vijay.
Fine, thank you. So, okay, I was just discussing like Python, Spark with Python and Spark with Scala, right? The difference, right? So both has got Spark APIs are equal to both the languages. Scala has got some compile time type safe language, so it offers certain features that cannot be offered in PySpark, like data sets. You won't see the data. Compile time checks given as a awesome developer experience. So data sets can only be implemented in languages. Data, there is called a data frames and data sets, right? Data sets can be implemented in a languages that are compile time safe. Java and Scala are compile time safe, so they support data sets. But Python and all language, there is not, they are not compile time, so they won't support data. They won't support data sets. So they have got only support of data frames. This is not an advantage, I can say. It's not an advantage of Scala over Python. In Scala, data set shouldn't be considered to be a huge advantage, I'm saying, because even in this, in our regular in these applications, right, data frames are only mostly used, right? So if you talk about the performance wise, regulars, if it even there is a, yesterday I was just saying, right, when comparing, when I am comparing Python and Scala, so Scala is 10 times faster. Don't get into the opinion that it's an advantage of Spark with Scala over PySpark. It's language wise okay, but if I talk about PySpark and Spark, right? So PySpark is not executed regular like a regular Python code. Observe one sec. PySpark code is not executed like a regular Python code. To say that Python is slower than Scala, Python code is not executed like a regular Python code. Here you cannot check that performance comparison is relevant, because PySpark is converted into Spark SQL and then executed on a JVM cluster. So traditional, if we talk about the Python code execution or Python environment, right, benchmarks for other executions are irrelevant for PySpark. So the normal other Python code, PySpark code execution are different. So don't think like Python here, Python code okay compared with Scala, but PySpark execution is different, right? And also PySpark, we have got that in PySpark we have got data frames. We have got huge libraries for data frames. Not only that, we can just take the help of pandas data frame. In PySpark data frames, you can take the help of pandas. There is a module in Python, right, where we say data frames creations. So PySpark data frames can be converted to pandas data frames. There is a command like two pandas. If you say, it will be converted to pandas data frames. So all the data, so it collects all the data on the driver node and negates parallelism benefits. It gets the parallelism benefits of regular PySpark data frames, right? Even you can make use of, even yesterday some query asked, right, on this, can I make use of pandas, right? Yes, we have got like two pandas to convert to pandas data frames. So the main features what we see here in PySpark, see both RTDs and data frames, data frames mostly used. So it's nothing but schema RTDs. We call it as data frame. So I'll just brief you about that data objects, RTDs and data frames. So hope you have understood the advantages and differentiations between Python, Scala, and Python mainly designed for, it is used for coded with, and features of it, main features in memory computation, right? And on demand we can execute them. Fault tolerance, and also like fault tolerance model, persistence feature, distributed execution, right? Yes. So it's a data flow language. I said it's totally, it's a data flow language. The output of one will be the input to the next flow, right? The output. So even it's fault tolerant model. It's got a good fault tolerant model. Persistence feature. The executed transformations can be reused by the other flows, right? Yes. So here, if you talk like fault, that has got a powerful fault tolerant model. It has got a powerful fault tolerant model. So here, RDD, we have got concept like RDD, Spark data objects. Spark data objects we call it as RTD, resilient distributed data sets. Resilient distributed data sets. Generally, how this RTD is going to get created. So in Spark, everything deals with RTD, and later we got data frames. Data frames. Mostly, my concentration will be mostly on data frames. Schema RTD, we call it as a data frame. RTD with the schema, we call it as data frame, right? So you need to have some little knowledge on this RTD before you go with the data frames. Spark data objects RTD. This RTD is divided into partitions, multiple partitions, right? P1, P2, P3, P4, P5. These partitions are distributed across multiple RAMs of multiple slaves. RAM. Slave 1, slave 2, slave 3. So here, a Spark data object divided into partitions. The partitions are subdivided. The partitions are distributed across multiple RAMs of multiple slaves and are processed parallelly. That's why very high speed for Spark we say parallel processing, distributed execution, right? So in slave 1, slave 2, slave 3, slave 1, slave 2, you can get some multiple queries here. You may, so this multiple, this your data, for example, think that like 2 GB data divided into partitions. That partitions are distributed across multiple RAMs and stored. Otherwise 20 GB data you take. 20 GB, right? Each RAM of 4 GB RAM. So 4 GB data, 4 GB, 4 GB, 4 GB. In this way, 4 GB data stored in each RAM of each slave. So when it is going parallelly, when execution is going to happen parallelly, suddenly if any slave goes down, right? Yes. Then how? I'm saying like Spark has got a powerful fault tolerant model. So generally this is one RTD. Once this, think that it is successfully executed, you got the output. It's loaded and you have performed some business logic on it, you got the output. The output is taken as the input by this RTD2. The output is taken as input by the RTD2. RTD divided into multiple partitions distributed across these RAMs of multiple slaves. You are applying some business logic, executed, you got the output. The output is taken as input by RTD2. RTD1 output, this output is taken as input by RTD2. So applying some, for example, on RTD1, you applied some business logic. Some 20 lakh records are there. 20 lakh records are there. You perform some filtering operations. After filtering, you got some 10 lakh records. 10 lakh records is the input to RTD2. And then RTD2, you perform some kind of transformations. Right? You want some merging operations or sorting operations, any operation you want to perform on this RTD2. After performing that, you will get an output, right? The output is taken as input by RTD3. On the RTD3, again, you perform some kind of transformation or filtering or some operation you perform. You get the output. It's taken as the input by RTD4. So this entire thing we call it as a data flow. This entire thing we call it as a data flow. The output of one is the input to the next. The output of this will be the input to the next. The output of this. These RTDs won't execute parallelly. Observe this. This RTD1, RTD2, 3, 4 won't execute parallelly, because simultaneously to execute RTD1, 2, 3, 4, RTD1 need to process, and if it gives the output to RTD1, then only RTD2 computes, right? RTD1 should compute and its output should be given. It's like a pipeline, right? It's a pipeline. The output should be collected by RTD2, but if they go parallelly, RTD2 cannot get the input, right? Once RTD computed, RTD2 gets computed and it gives the output to the next one, RTD3. Until then, RTD3 cannot be computed. It cannot get the input. So on every RTD, you're performing some kind of transformations, filterings, or operations, right? Then output will be collected by that computes sequence one after the other, right? RTD by RTD. But this RTD already, one RTD has got a very huge size. It is going to be divided into multiple partitions, many partitions. The partitions are being stored across multiple RAMs of multiple slaves. And after processing, that output will be collected by the next one. Within the RAM cannot accommodate these many RTDs. Think that each RTD, think it is RTD size. This is 20 GB. This RTD like 14 GB. This is 10 GB. 10 GB. So if you're filtering, right, the size of this, it decreases, right? 20 GB. So all these RTDs cannot be accommodated by the RAM. Once the first RTD loaded, think that entire RAMs got filled. Assume RTD1 loaded into your RAMs. So RAM level processing, memory level processing, in-memory computing, I'm saying. Spark has got why this much of high speed? Because of memory level processing, in-memory computing. So storage and processing, everything happening within the memory, right? So that's why high speed processing. Okay. That output is given input as an input to the next one. So RTD1, when it is loaded into the RAMs of multiple slave machines, think that all your RAMs got filled. It cannot accommodate RTD2, right? So for example, RTD2 or RTD3. Once RTD2 is ready, when it has collected the output into input, when RTD2 got loaded into the RAMs, see these 4 or 5 RTDs or 10 RTDs or 20 RTDs at a time, you cannot load into a RAM. 10 RTDs or 10 data objects or 20 data objects or 30 data objects, you cannot load into the RAM at a time. They cannot be accommodated. First RTD1, you apply some business logic. The output is collected by RTD2. So in a simple way, I can say first RTD1 means using Spark context. If you are loading a text file, give the path of this file, some sample.txt or any file, right? So this is nothing but an RTD creates. Using Spark context, if you are loading a text file, right? RTDs, this text file, think that a huge data set of like a 5 GB file. This is RTD. This RTD, what happens? It will be divided into multiple partitions stored across multiple RAMs of multiple slaves. You will apply some logic. After this output, you get the output, right? The output is the output is taken as the input by this RTD2. RTD2 has collected it. RTD2 has collected it. Once RTD2 is ready, RTD1 going to be removed from the RAM. Observe here. When RTD2 is ready, RTD1 gets removed from the RAM. When RTD2 compute, you will apply some logic on this, transformation on this, or some operation on this. You get the output. The output is nothing but R3. The result is stored as R3. See, R1 equal to some load operation. On that R1, if I perform some filter operation, if some condition you give, you will get the resultant R2. This R2, RTD2. When RTD2 ready, this R1, whatever the partitions, everything will be removed from the RAM. Now only R2 partitions are available in the RAM. Because to accommodate the next RTD, next on this R2, I perform some mapping operations or some other operations, right? R3 is created. So R3 has taken the output of as input, right? Now R3 gets loaded, R3 partitions gets loaded into the RAM. R3 partitions gets loaded into the RAM. Once it is ready, this gets removed from the RAM. Now only R3 partitions will be available within the RAM. You apply some logic on this R3. On that R3, you apply some, you will get R4 as the result. So on R3, the output taken as R4 as input. So when R4 is ready, R3 gets removed from the RAM. Once this is the entire data. Okay. When R4 execution completed, R4 also gets removed from the RAM. Now what is present within the RAM? First RTD1 was there. When RTD2, then RTD1 got removed. When R3 or RTD3, RTD2 got removed. RTD4 or R4, R3 got removed. Now total execution finished. This R4 also got removed. You will collect the output and it gets removed, right? Now what is it in the RAM? RAMs are empty now. Now you can trigger next another job, right? You can trigger another job, another flow, so that again one by one RTDs gets loaded, and the same process is going to happen. Finally, the last RTD also gets removed. Now nothing will be within the RAM.
Vijay sir, one question. Currently with the map reduce jobs, we can similar same stages, looks like it does the similar stages, but it stores the file for every stage, input and output, it stores on the HDFS location. And then it uses the same file for the next stage, but it maintains all those files until the job is completed, and then it removes those temporary files. So, but we, in case if a job fails at a particular time, like let's say at a place of RDD3, we can go back and see those files and see which particular message or which particular is bad, and we remove it and reprocess or whatever. The map reduce jobs allows us to do that type of troubleshooting for currently. Will Spark job let us see what are those in this case, it is RDD, correct? If we persist the RDD, we can still see those data, correct? I think.
Okay, one
I
second.
answered my own question, I guess.
Okay, so just
Sir, one question, sir. Sir, every RDD we are processing one by one. So
yes.
where is parallel processing here?
Parallel processing. Okay, yes, good query. So here R1 is divided into some 50 partitions, assume. It's a big data object, right? This is the first only available. R2, R3, R4s are not available as of now. R1 only available, right? R1, it has got a big data object, multiple partitions it has divided. Think that some 40 or 50 partitions. These 50 partitions executes parallelly. These 50 partitions are loaded into
Okay,
50,
okay.
50 they will be
So
executed
those-
parallelly, and you will get the result. You will get the result. That result is nothing but the outs here. The output what you get from a RTD is an RTD only. Whatever on RTD, if you perform any operation, the output whatever you get is an RTD. Data frame also, on a data frame, if you perform any operation, the resultant is also a data frame, a new data frame you get. But the original data frame is immutable. That the original RTD is immutable. It cannot be modified. So they can be as it is. But on that type of perform operation, you will get the result that is not a new data frame gets created.
Okay,
So
so the
this,
parallel processing is not with the RDDs, it is with the different
yes,
nodes,
yes, different. This is divided into multiple partitions, right?
partitions,
The
different
partitions, those partitions are going to get executed parallelly. For example, you got some 5 GB data, assume that is divided into multiple partitions. For example, very small labor example like you. A building construction work is there. That is a big job, big work that you divide into multiple tasks, right? And you will give to multiple, you will assign to multiple labors. They'll be working parallelly and you will be getting the result. In the same way, your big data object, R1 is a big data object that is divided into multiple partitions. Those partitions are going to get executed parallelly, that too within the RAM level, right? You will get the result fast. That is nothing but collected as the R2 or RTD2. Next, yes, RTD2 again, the partitions. So this RTD2 is there. Once it is ready, right? Then when it is ready, when it has collected the output of this R1, total R1 gets removed from the RAM. The next RTD to be accommodated, the previous one should be removed, right? So R1, R2, R3, R4 still I keep on accommodated or loading into the RAMs, right? Then the RAM cannot accommodate the further incoming RTDs. So what happens when this next one is ready, the previous one should be removed. So there is a query asked just now, MR, map reduce and Spark. A query was asked, but just the difference map reduce and Spark, right? Hadoop, we use MR, map reduce. Mostly Hadoop Hadoop goes with map reduce only. Spark is 100 times faster. 100 times faster than MR, map reduce. Spark is the Spark speed 100 times faster than map reduce speed. And the other things, why this map reduce is got outdated today, because first thing, any transformations are there. Transformations cannot be reused. Cannot be reused means if you have got already the knowledge of this map reduce, right? If so yes, Gunaya city, right? Yes, I'll come back to your query. So transformations cannot be reused in map reduce. For example, if you're performing any task, you performed a task, you got the output. Tomorrow I cannot use that output as input to the next flow. Tomorrow I want to perform a new task. That task requires the output of this whatever task we did yesterday, right? So it cannot reuse, means mapper phase, reducer phase. There are two phases in map reduce, mapper and reducer, right? Reducer is the one where you get the output storing in the HDFS, right? But tomorrow, if you want to perform a new task without initiating mapper, the directly reducer cannot be initiated, right? Compulsory again, you need to execute mapper. Think that whatever the mapper does is same. Still, you need to initiate the mapper every time. You need to, without mapper, they cannot, reducer cannot. Always the reducer takes the input of the mapper, right? You cannot redirect the reducer to take the input from the HDFS. Reducer cannot take the input from the track. Yes. So this is what resilient distributed data sets, right? Resilient distributed data sets. Fine. So there is some queries asked, right? R1 output taken by R2. So see this flow, right? R1, R2, R3, R4, R5, R8. This first flow. See this first flow. R1, R2, R3, R4, R5, R8, R11. This flow executed. This flow executed. Second flow. What is the second flow? R1, R2, R3, R4, R6, R9, R12. Flow 1. R1, R2, R3, R4, R5, R8, R11. Flow 2. So these are the three flows, right? The first flow is this. Second flow is this straight line. Straight. Third flow is this. Third flow is this, right? Yes. Three flows are there. First flow executed. Assume the first flow has executed. Observe in every flow, the first four steps are common, right? In all the flows, first four steps are common, right? But when do you execute the second flow, second task, right? Again, you are supposed to execute from R1, R2, R3, R4, R6, R9, R12. Third flow also, again, I need to re-execute the first four flow. When R1 is, see this first flow execution. Flow 1, you see. Everyone, R1, R2, R3, R4, R5, R8, R11. See, when R2 is ready, R1 gets removed. When R3 is ready, R2 gets removed. When R4 is ready, R3 gets removed. When R5 is ready, R4 gets removed. When R8 ready, gets removed, right? So total execution finished. Nothing is present in the RAM, right? Flow 2. Observe this flow 2. Again, you are re-executing from the starting, right? When R2 is ready, R1 gets removed. When R3 ready, R2 gets removed. Okay. R6 ready, R4 removed. When R9 ready, this removed. When R12 ready, removed. So all the flows are executing from the starting, but if I say all the four steps are common, means if I say persist this, if I persist means if you're persisting, right, what happens whenever I execute flow 2, whenever you are persisting R4 means R4 is available, right, in the RAM to get the output. So your flow starts from R4, R6, R9, R12. Previously, R4 was not available in the RAM. Now R4 is available in the RAM, right? Directly flow 2 can execute. No need to execute from R1 to 4 steps got reduced, right? R4, R5. If flow 3 also, directly you can start from R4, R7, R10, and R13. R4, R7, R10, R13. R4, R7, R10, R13. So the flow is decreased, right? Persistence, right? Yes. So we are already executed transformation. R4 is executed, right? In flow 1, the same transformation output is used by the flow 2. Again, it is not executing from the starting, right? Flow 3 also, right? Executing from R4, not executing from R1, because you are persisted R4. Persisting an RTD means making the RTD available in the RAM. Okay, fine. So this everything we'll be discussing, but observe this some course content you have asked, right? So PySpark introduction. What is PySpark? Need for
Sir,
PySpark?
one question.
Yes.
So if R4 is existing, it always exists in the RAM.
Yes.
Oh, even though the first flow is loading, R6 is loading, R6 and R7 is processing.
So when
Whenever
R6 when R6 is ready, R4 won't be removed. When R9 is ready, R6 gets removed. When R12 is ready, R9 removes. R12 also removed. R4 existing in the RAM now.
Okay,
Now,
okay, sir.
when flow 3 can execute from R4, R4 is already available, right?
Okay, sir, I got it.
So
Thanks.
persisting an RTD means making the RTD available in the RAM, even though the next RTD is ready. Generally, when R2 is ready, R1 removed. When R3 ready, R2 removed, right? When R6 is ready, R4 won't be removed. R9 ready, all this will be removed, but R4 still will be available. So flow 3 can start from R4, already R4 available in the RAM, right? No need to execute from the starting. For example, you got some big flow R1 to R90. R50 flow used by 3 flows, right? R50 output is used by 3 flows. If you persist it, the flow 2 can start from R50, 49 steps decreased, right? If there are common steps. This flow 3 also can start from R50. No need to start from there. Means at least one flow should be executed first. All 90 steps need to be executed first. But the second flow can start from R50. Third flow should come from R50. Okay, fine. So these things in detail we'll be discussing separately, right? And our regular sessions. So this is, and one query was asked. When R6, so the fault tolerance model I'll be discussing in brief, right? Next, what happens if any slave goes down? When R2 is collecting input from R1, suddenly if R1 is down, suddenly when R3 is collecting output from R2, suddenly R2 down. So how this is going to be happen? There is a big process to be discussed. So this is the course content. What is Apache Spark? Need for Spark, PySpark web applications, web UI, PySpark Spark session, Spark context, parallelizing, repartitioning, coalesce, broadcast variables, accumulator, PySpark RTD computation, operations on RTD, persistence options, how you can persist in the memory and SCR, disk and disk and memory and disk, PySpark core computing, fault tolerance model, different ways of creating RTD, creating Spark objects from Scala objects or from Python objects, aggregations over structured data, reduced by key, groupings and aggregations. Groupings and aggregations, right? Single grouping, multi groupings, group by key, reduce by key, various transformations, various built-in transform functions. Various actions. If you perform the action only, the entire data flow gets executed. Whatever data flow I discussed, right? This entire flow 1 gets executed if you perform an action only. Else it won't be executed, right? Count by key, count by value, sort by key, zip, union, distinct, all these are actions and transformations. Now coming to this main part, right? PySpark SQL, data frame concepts. Okay. So PySpark, right, into making data structured using functions, data frame API, like creating a data frame, empty data frame, okay, converting data frame to pandas. So here many functions are available, right? Yes. Show function, struct types, row class, column class, select, collect with column renamed, where, filter, drop duplicates, order by, group by. So we have got many functions. PySpark, right? Union, all, union, UDF, map, plot map for each sample, fill null, pivot, and SQL functions, right? If I talk about this SQL functions, aggregate functions, window functions, date and timestamp functions, JSON functions, read and write JSON, right? Built-in functions. We have got many PySpark built-in functions: when, expr, lit, split, concat, substring, translate, regular, overlay, timestamp to date format, date, array contains, count, distinct, some rank, dense rank, percentage, right? Type. We have got some lit function, type lit from JS1 to JS1 tuple get JS1, right? PySpark external sources working with pure SQL statements, Spark and Hive integrations, and MySQL integration, working with CSV, working with JSON, transformations and actions on data frames, narrow and wide transformations, new columns, dropping columns, renaming columns, adding or new rows. Window function, writing data back to external sources, creation of tables from data frames, deployment modes, local and cluster modes, PySpark applications, stages, task, driver, executor, building Spark applications, pipelines, deploying Spark apps to cluster and tuning, performance tuning, and streaming concepts in integration with Kafka and PySpark MLlib, right? This are apart from this, I said I'll be giving knowledge. I will be taking sessions on some HDFS, Scoop, Hive, Yarn, right? Some nearly some 10 to 15 sessions on this HDFS, Yarn architecture, Scoop, and Hive, right? Yes. So this is what the course content, right? Yes. Right. So if you got any queries, you can go with your queries. But from the next week onwards, we are going to start off with this, right? And
small regarding timings. Is it possible to take daily 1 hour?
so this timings will be like 4:30 to 6:30 on Saturday, and Sunday Saturday 4:30 to 6:30, Sunday 4:30 to 6:30, or if possible I can extend by half an hour. If
upon the weekends, weekdays, is it possible?
at the weekdays already Spark with Scala is going on, right? So PySpark is scheduled for weekend, right, as of now.
Okay.
Some are attending for both, right? Weekend Spark and Scala and Spark PySpark, right? So from the next week, today, this week, right? Just introduction to this PySpark, but in the next week, we'll be going with this, right? Next Saturday at 4:30. So everyone, you can attend the session next Saturday at 4:30, same time, right? To see more on this. Fine. Any queries from your side, anyone? So clear notes will be provided. Software will be provided, and different environments, how to run this. I'll be briefing you. I'll be demonstrating the everything. I'll be forwarding to your Google Drives and notes to your Gmails. Every session is video recorded. You will be getting the recorded video of it.
So
Yeah, Python basic.
Python also will be covered in this course.
So Python basics and revisions, right? For 2-3 days before I start with the practical part, I'll be discussing it, right? Yes. Before I go with the practical part, I'll be just briefing you or brushing up with all the Python syntaxes, right?
No, one question, Vijay. Is it Python already required to join this course?
Python, yes.
Okay,
Python
without Python, we cannot join this course, right?
Python is the prerequisite for this.
Okay.
But Python is not a kind of language where you need to go and learn, right? It's you can update by yourself also. It looks very simple and easy. Fine.
So without Python, can I continue this course?
So I'll be giving the basic knowledge, like 3 days I'll be just discussing about that Python. Meanwhile, you can work with this. I'll be forwarding some kind of notes. If you can follow that, and if we can cope up, that's fine.
Okay.
On Python, right? Python notes I can forward you. So the course goes for 2.5 months. Means like nearly 10 weeks, right? 2.5 to 3 months, right? So in brief, in depth, I'll be discussing about this. Fine.
Sir, can you take few classes for at least troubleshooting Spark jobs?
Yes. That I'll be
Because
Spark.
that's more important, because once we do the real work, that is what we have to deal with.
Yes, definitely. I'll show you that stages, or all about your stages, tasks, executors, drivers, Spark jobs, everything. I'll be discussing it.
Sure. Thank you.
Okay, fine. So fine. If I'm done with your queries, then I'll sign off for today. Meet you next Saturday at 4:30, right? Next Saturday, like we'll go with 4:30 to, like we'll extend the time, be like for 2 hours. So sorry for that voice and this disturbance, right? So next week we'll be going with okay, without any such kind of things. Okay, fine. Okay, thank you all. We'll meet you next Saturday. Fine. So this course content will be forwarded to your mails. You can check it once, right?